Hello and welcome. Today, we're going on a journey through the physical map of India, which is honestly a country that holds some of the planet's most dramatic and diverse landscapes, all within its borders. So let's dive right in.
So, this is really the big question we're tackling. I mean, think about it. How can one single country have landscapes that are so incredibly different? Well, as you're about to see, these extremes aren't just neighbors, they are deeply, fundamentally connected to one another. So, we're going to take a trip through these incredible places, starting way up in the icy heights of the north, then moving down south through that vast, fertile heartland, and all the way out to its most remote islands. Let's get started. Okay, our first stop has to be the colossal mountain range that really defines the entire subcontinent, the Himalayas. For centuries, people have seen them as these great northern sentries, just this massive physical barrier, protecting and shaping everything to the south. But honestly, just calling them a barrier is a huge understatement. The Himalayas are more like the subcontinent's engine. They block those frigid winds from the north, they store unbelievable amounts of water, as snow and ice that feeds the great rivers, and, as we're about to find out, they are the very reason the plains to the south even exist. To wrap your head around this massive system, it's actually easiest to think of it as three distinct, parallel ranges, all running alongside each other. So way up in the far north, you have the Himadri, the Great Himalayas. Then in the middle, you get the Himachal, or the Lesser Himalayas. And finally, closest to the plains are the Shiwaliks, also known as the Outer Himalayas. And you can really see the difference when you lay them out side by side like this. The Himadri, it averages a staggering 6,000 meters in height with peaks like Everest. It's basically a granite core that's always covered in snow. Then you've got the Himachal, which is lower, and it's where you find all the famous hill stations and those beautiful, picturesque valleys. And then you have the Shiwaliks, which are much, much lower and geologically completely different. And this is a really key point. The Shiwaliks are the youngest of the three. They're not made of that hard pressure-cooked rock. Instead, they're made of loose, unconsolidated sediments. We're talking sand, silt, gravel, basically all the stuff that's washed down from the higher Himalayas over time. And because of that, they're geologically unstable and, very prone to landslides. This unique geology creates a really special feature. Tucked right between the Lesser Himalayas and the Shiwaliks, you find these long, flat-bottomed valleys called dunes. So the story goes that rivers, blocked by the rising Shiwaliks, created these temporary lakes. Those lakes then filled up with gravel and alluvium. Eventually, the rivers cut through the mountains, leaving behind these perfectly flat, fertile valleys. And of course, Dehradun is the most famous example. Okay, so we've seen the mountain engine. Now, let's see what it actually builds. Right from the foot of the Himalayas, we step into the Great Northern Plains. And believe me, they're called the granary of India for a very good reason. The origin story of these plains is just epic. Over millions of years, the great rivers born in the Himalayas, the Indus, the Ganga, the Brahmaputra, they carried trillions and trillions of tons of eroded sediment down from the mountains. And they just deposited all of it in this vast depression to the south. What this created is the largest, flattest, and most fertile stretch of alluvium on the entire planet. Now, you should know, not all of this amazing alluvial soil is the same. Geographers make a distinction between Bangar, that's the older stuff, found on higher terraces, and it's a bit less fertile, and Kedar. The Kedar is the good stuff. It's the newer deposit found right in the river floodplains. And because it gets a fresh layer of silt every single year during the floods, it is exceptionally fertile. This is the agricultural heartland. And get this, look at the human impact of all that fertility. This one single geographical feature supports over 40% of the entire population of India. It is one of the most densely populated regions on Earth, and it's all thanks to silt that came from the Himalayas. All right, so we've been in the fertile heartland. Let's now journey out to the fringes, to the landscapes that stand in really sharp contrast to those lush plains and icy mountains. So, to the west of those fertile plains lies the Great Indian Desert, also known as the Thar Desert. It's a totally different world, an arid landscape of shifting sand dunes that stretches west from the ancient Aravalli Hills. Life here is pretty much dictated by the scarce water, with seasonal streams like the Luni providing just enough to support little pockets of civilization. Now let's head far from the mainland, where India has two totally different major island groups. Over in the Bay of Bengal, the Andaman and Nicobar Islands are actually the peaks of a submerged volcanic mountain range. Then, all the way over in the Arabian Sea, you have the Lakshadweep Islands, which are coral atolls. These amazing ring-shaped reefs built up over thousands of years by tiny marine organisms. So, we've seen the peaks, the plains, the islands, but now for the most important part. Let's see how these seemingly separate worlds are actually just one big, interconnected system. Right, so we're back to that first big question. How does a wall of ice relate to a vast, fertile plain? Well, the connection is incredibly direct and powerful. It's just a beautiful example of geographical cause and effect. Okay, so here's the crucial point. Think of it like an engine. Step 1, the Himalayas act as a giant water tower feeding the rivers. Step 2, those rivers flow down, eroding the mountains and carrying away tons of silt. Step 3, all that silt gets deposited, layer by layer, in the basin to the south, creating the northern plains. And Step 4, those plains become the cradle of civilization. So you see, without the mountains, there would be no plains, period. It's one continuous process. And that right there is the key takeaway from our journey today. India's geography isn't just a random collection of features. It's a single, living, dynamic system where the mountains literally build the plains, and the plains, in turn, sustain one of the largest concentrations of humanity on the entire planet. And that leaves us with one final and pretty urgent question. This powerful engine has been running for millions of years, shaping not just the land, but history and culture. But as our climate changes, affecting the glaciers, the monsoon patterns, the river flows, you have to wonder, just how resilient will this incredible system prove to be?